So thanks everyone to join us today at the online live event tour. I'm the host from AI Camp. So before we get started, just want to do a quick introduction on AI Camp. We are a global online platform for developers, engineers, and data scientists to learn and practice AI technology. With the mission of make AI available to all developers, AI Camp have grown to over 50,000 tech engineers in the group, have hosted over 300 local tech meetups, workshops, boot camps, large tech conferences, and live stream most of the tech talks globally. We have local study groups in major cities in the US, a few cities in Europe, India, China, Australia. You can take a look at the website to see our upcoming tech talks, workshops, and crash courses that we offer. So here's our events for the upcoming weeks. Starting next Tuesday, we will have a 2-week online crash course on build machine learning pipelines. Starting January 31st, we will have a 2 weeks online crash course on auto machine learning in practice. On January 30th and February 1st, we will have the tutorial to build shared AI service. And on January 30th, we will have a meetup in San Francisco to talk about the understanding of machine learning. So please join us if you live in the area. Otherwise, please join us online to listen to the live stream. And most importantly, we will have our AI NextCon Seattle conference from January 23rd to 26th. It will be a 4 days, 50 plus tech lead speakers, 60 plus tech talks, 6 workshops and collabs. You will meet lots of great people, so it's time to learn and to build up your connections. So please check out our website for more details. I know there's lots of information to take away, but here's more coming. So back to our main topic today, which is package management for machine learning models. We're excited to have Garrett, the founder of Guild AI. So in today's talk, Garrett will discuss how Guild AI combines the proven effectiveness of package managers with novel features to enable model reuse for application development across a variety of use cases. So without further ado, let's welcome Garrett.
Hello, thank you. Can everyone hear me okay?
Yes, we can hear you.
Okay, great. Let me share the screen. Okay, before I continue, can everyone see that?
Yes, we can see that.
All right, terrific. Well, Happy New Year, everyone. I'm happy to be able to talk to you today about this topic. It's kind of a weird topic. It's a bit of a strange synthesis, but I think hopefully at the end of this, you'll see where I'm coming from with it. But it combines a couple of things that are near and dear to me. Package managers. I have a lot of experience building package managers. It's strange I've managed to stay in package management territory for most of my career. In machine learning. And I'm going to try to bring these two together and hopefully make a case that would sort of outline what I think is a compelling future for machine learning and packaged software within that ecosystem. Okay, let me talk a little bit about Guild AI to start. I'm a founder of Guild AI. Guild AI is an open source project. It's released freely under the Apache 2 license. It's a command line tool. So we're going to see some sample commands in this presentation, but all the commands are run on the command line with Guild command. The purpose of Guild is to formalize and automate machine learning operations, and we'll see what that looks like. When you run an operation in Guild, it is captured as a unique experiment called a run, and we'll see plenty of that in our presentation. And finally, Guild has package management capabilities, and that's sort of what I want to talk about in this presentation. And I want to start with an example here. I'm going to guess that most people here are experienced with Python, being sort of interested in machine learning, and Python is the lingua franca of machine learning as a programming language. This is an example of installing a package called TensorBoard. And if you have any experience with TensorFlow, you've probably seen at least examples of TensorBoard being used. But that's not really the point here. The point is that we're installing a computer package, a software package, using a package manager called pip. Pip is used to install Python-based software packages. And we run pip install TensorBoard, and pip goes out and downloads the files and resolves dependencies and installs a bunch of things. And at the end of it, we get to run this command called TensorBoard. And this is available as a program that was installed as a part of the TensorBoard package. And so I want you to keep in mind these two points, because I'm going to keep coming back to them throughout the presentation. One is the installation of a package. So that's the first part up there. And the second is using what you installed. And that's really obvious in the case of packaged software, but it may not be obvious in the case of machine learning models. And that is what I'm going to talk about. Okay, but first, let's just cover what we mean by software packages. So software package is a named and versioned software unit. So you generally install something like an application or a library, maybe some configuration. Almost always they are discoverable, so you can search them in repositories or app stores. They are installed with required software. So there are other packages that are required by a package, and those are installed alongside of those to simplify the process of installing. And the purpose really of a package is to hide complexity. So that's the overview. This shouldn't be controversial. This is not new. Everyone who has used software before is familiar with these concepts. But how do we apply this though to machine learning? So that's what we're going to talk about. Okay, let's use an example here. And this is an example of using Guild AI. It's the Guild command here. So we're running a command. Guild command is called search. And we're searching for something called MNIST. And yes, we're using MNIST as yet another example, or yet again as an example of something in machine learning. But I mean, it is the Hello World example, so we're going to use it again. I know people are probably tired of hearing about MNIST, but here we are in 2019, still talking about it. Okay, we're going to use that as an example because it's quick to train. Even though I could have picked something more interesting because this is still screenshots. Anyway, we're going to search for MNIST, and we've got a couple hits here. So we have two packages that are associated with MNIST. We have a gpackage Karist MNIST and gpackage MNIST. These are packages, and they happen to be standard Python packages, so you can actually use pip to search for these. But Guild returns results that contain models. So both of these packages contain models, and I'll talk about what that means. First, I want to install one of them. So I'm going to install the gpackage.mnist package using the install command, Guild install. And again, this is a standard Python package, so you could do the same thing with pip. Guild just happens to provide an install command, but it's the exact same thing. So any dependencies that this package has will be resolved just like any Python package. But now we've done something to our system. We've installed this package. So what does that mean in the context of machine learning models? Well, it turns out this package contains two models, and those two models are now available on the system. And we can tell they're available by listing them with the command Guild models. And we have two of them, a CNN, which is a convolutional network, and a logistic regression. So these are the two models that map to the original intro and expert models from the TensorFlow example. That's since been updated to use Fashion MNIST, but these were the original models. So this is sort of a hello world example. But anyway, they're installed on our system. What now? Models in Guild have operations, and it's the operations that we're going to run. So remember before in the TensorBoard example, we installed something and then we ran it. We did something with it. Well, in Guild, models have operations, and it's the operations that you run, and you enumerate operations using the operations command. So we run Guild operations, and we see the two models, and each of the models has an evaluate and a train operation. Now, with this, we can run an operation using the run command. So we're going to train our logistic regression, our simple classifier, using the train operation. So we say Guild run log reg train. Guild prompts us with some of the flags or hyperparameters that we'll be using. And we hit yes, and off it goes. So we've seen this a million times. Off it runs very quick and finishes. this is an example of what you do with a model when you install it. You run an operation. And when you run an operation in Guild, you get a run. A run is an artifact that Guild formally tracks. And you can list the runs that are generated for your system using the runs command. Here we have one run. This run has an ID on the left. It lists the operation that was called. So in this case, the operation is train on the logreg model, which is part of the gpackage mnist package. We've got a date and time, and the status is completed. Okay, great. Runs in Guild are standard file system-based artifacts, and one of the common things to discuss that you'll do with a run is to look to see what was generated and work with those files. In this case, we use an ls command which lists the files for the latest run, and we're interested in viewing the model checkpoints, just as an example. And what I want to highlight here is that when you run an operation in Guild, it's a standard file system artifact. It's not storing it in a database someplace. It's not off in some cryptic location. It is there on the file system that you can discover with any file system utilities. It is basically an automation of what you would typically do. When you typically, without Guild, run some sort of training operation, you generally create a directory, and then you put your models. You say, model dir as a flag, and you put them in there. This is just doing that for you automatically and giving you tools to manage that process so that you don't have to deal with the lower level file system semantics. Okay, so here we've listed our checkpoints just to confirm that we've actually trained something. The next thing in our workflow will be to evaluate. So we run the evaluate operation. And so it prompts us, and we hit yes, and off it goes. So I want to call attention to a couple things here: the resolving trained model dependency and the resolving mnist dataset dependency. I'm going to talk about dependencies a little bit later, but Guild has a dependency resolution feature which will ensure that whatever an operation needs is provided for that operation. And I'll highlight that. But in the context of packages and sort of packaged models, this is the running part. This is the I'm using it. And it's different from using traditional software. Traditional software you execute as a command. You just run the program, or you load it as a shared library, or you read it as a file. Models are different as packaged units. In the Guild view, they define operations, and those operations are run. So that's how you use it. You install the model, and you use the model or models by running operations on them. If you were face-to-face here, I'd stop and say, does that make sense? And hopefully it does. So we'll assume it makes sense and proceed here. I have no idea who's out there. I'm looking at a screen here. All right, so we now have a second run. We run Guild runs. Also, I can't hear any of the laughter that's going on because I know everyone is laughing at these little quips. So it's all in my head. In addition to listing the runs, Guild provides a host of other features that let you inspect and compare and diff what you created, what you ran. So you run these operations, the operations generate runs, and then you do things with the runs. An example of that is I want to view my results here, my runs, in TensorBoard. And TensorBoard is a tool that commonly, it ships with TensorFlow and is certainly used with TensorFlow, but it's increasingly used by other frameworks simply as a visualization tool because there is no necessary dependency on TensorFlow itself. As long as you write files to the TF event log format, you can use TensorBoard to view them. So frameworks like PyTorch and others are starting to use TensorBoard. Well, the frameworks themselves aren't using it, but developers can use, there's a package called TensorBoard X that lets you write these scalars as events, and then you can just use TensorBoard. So in this case, the two operations that we've run are reflected here in TensorBoard. And this is standard TensorBoard. This is not a Guild. The Guild doesn't do anything here. It just serves it. So we're viewing the results through TensorBoard in this case. Okay, so what just happened here? We installed a package that contained a couple models. we use the models available in the package. And in this case, we trained a simple classifier on MNIST, and then we evaluated the model on the test data. Big deal, right? We've seen this. This is like running Hello World or our samples. Everyone's done this. Who cares? So I want to talk about the same exact workflow, but with probably a more compelling example, which is object detection. So object detection is this. You've got an image and you're asking a model to both identify objects in the image and also classify them. It identifies them with bounding boxes in this case. There's a form of detection called segmentation, which actually classifies individual pixels. But this is an example. We're going to use object detection framework from TensorFlow, but we're going to do it using this packaged model. Is install a package and use the model's formula. Okay, so in this case, we're going to install gpackage object detect models, which is a Guild package. Again, a standard Python package, but it happens to contain some models. So we list the models that were installed using the models command, and we're going to filter on object detect because we're just interested in those. So we see there's faster RCNN with a couple of different backbones, ResNet 50 and ResNet 101. This is an incomplete list, by the way. There are more object detection models available. SSD MobileNet V2 is a common detection model for constrained environments, mobile platforms. And then VOC annotated images, and we'll see what that is next. Looking at the operations for, let's say we wanted to train our detector with the ResNet 50 backbone. So there's a faster RCNN implementation of that. If we list the operations for that particular detector, we have 5 of them. We've got detect, evaluate, export and freeze, train, and transfer learn. And these, again, are all things that you can just run. So it's using this installed model as some sort of useful thing on your system. So let's go do that, see what that looks like. In order to train a detector, in this particular case, we're not just going to go download some hard-coded data set from the web. The whole point of doing this particular type of learning is to train on your own data. You can certainly use pre-trained networks, but those are going to be of limited use if you have a specialized field or specialized domain. And it's very, very common to train these detectors or classifiers, these computer vision models on your own images, your own labeled images. So to do that, we have to prepare them, and this is again an out-of-the-box installed feature that's associated with this particular package that allows us to prepare VOC annotated images. VOC annotated images are images that are annotated using a very specific VOC format. It's an XML-based format that describes where in the image a particular object is and what its class is. So we're going to run prepare, and we're pointing in this case to our own annotations and our own images. And so if you ever want to train one of these detectors, you need to go get your data and then you need to label it or find a labeled data set. But the process would be literally this. You would point to your annotations directory and you would point to your images directory. You would run prepare. And again, this just comes off the shelf as a part of this installed model. Okay, so once we've prepared the data, we're going to go ahead and train the model with the data, but we're going to use a transfer learn operation. We're not going to use train. In this particular model, train means train from scratch. And we don't want to do that because it will literally take weeks to train. So in our example, we want to do a transfer learn, and so we're going to use pre-trained network, which will accelerate our training. It'll give us sort of a set of pre-trained weights that we will then fine-tune using our own data in a learning process. So this runs for hours or days or however long it needs to, and it's done, and then at the end we evaluate it. And in this case, detection models are, they have there's a great variety of ways to evaluate these. And in this case, we're evaluating IOU, which is a measurement of how well how close the bounding box is to the actual labeled data. This is just, again, an example. But it's a real example, and it's an example that would make a difference to a business that wants to go build an object detector for whatever reason. You want to do classification and identifying objects for security. We went from 0 to a trained model, or at least starting the training in literally just probably less than a minute, just the time it takes to download the files. The same story that you would see when you install software on your phone, or on your Linux system, apt install, boom, all of a sudden you've got a very complex piece of software that's running correctly on your system. This is the idea. This is what we want to get to, and so this is why Guild does what it does. We want to be able to get useful machine learning operations sort of up and running as quickly as we can with little friction as possible, and we want them to work as expected. That's the premise of packaged software, and that is applied in this case to a machine learning model. Okay, we talk a little bit about operations here. We can sort of see that they're abstractions, right? They carve out some behavior, almost like a method on a class, and you want to pick the methods or the operations here that make sense to the users. In this case, researchers or engineers who are either building the models or they're building applications with the models. But the point is to let researchers and research engineers work at a high level rather than sort of being down in the weeds. And the weeds really is sort of what you're thrown into when you're in a README file with a set of instructions on how to use a model. In a lot of cases, you'll see models come with Jupyter notebooks, which is its own sort of form of weed. You can certainly run a notebook, but in a lot of cases, you have to parse it and think carefully about how to do what you want to do with the model. In the case of a README or a notebook, a package lets you just install it and use it. So it gets you from nothing to something useful in a faster time frame with fewer errors. And then I want to highlight here that we're running these as commands. We're not executing this as a Python API call. So we're in a POSIX environment. So this can be automated. This can be put into a container. This can be distributed. This can be run remotely or locally. There's a lot of flexibility in the way that these operations can be run and managed from an infrastructure and a system standpoint. If I pause like that, it almost certainly means I'm taking a sip of water. All right, so don't get nervous. Okay, how does this all work? So at the center of everything here is a guild file called guild file. A guild file is a plain text YAML file named guild.yaml, and it's located in a project root. I'm going to use the term project here somewhat casually. A project is basically a container, as a directory containing your model code. The code that if you're a model developer or an app developer, you put this code in, and it's what actually implements the model operations that we've been talking about. So I'm going to use that informally as a term project. It's not a package; it's a project. So it sits on your your sort of workspace. It's what you put in Git. It's what you manage as source code. A package is taking that stuff and putting it into an artifact that you can deploy. So project is the thing that you're actually going to edit. So the YAML file sits in your project root. It defines the models and operations. And it provides the information that you would use to package a project as an installable unit. Here's a really simple example. Again, our famous MNIST, but this is simple. It's got a couple of operations, train and evaluate. But you can see here that the Guild approach is to let your project be whatever it is. You implement it however you want, and then you decorate the project with a Guild file. So you add the Guild file. Guild doesn't want you to change your project or sort of adopt a new API or think differently about how you're gonna implement your model functionality. It will map its commands to your implementation. And so in this case, the main here tells Guild, run the train.py file located in the project directory. That's what that means. And in the case of main, run evaluate.py. And there's all sorts of different ways you can specify this in Guild. It's not just Python related. Well, in the next version, I'll talk a little bit more about this. The next version will support, the 0.6 version will support alternative runtimes. But in this case, these two examples are indeed Python main modules that you would run. And this is very, very common. I think 10 out of 10 examples that you see of, let's say 9 out of 10 examples that you see will use Python in some way. And these train and train.py and evaluate.py will contain the code that does the stuff that you want to do. And you wire this up by creating this Guild file, and that's how Guild knows what to run. Okay, so to now sort of make this a package, you just add this package element to the Guild file, and that just tells Guild what the name of the package is and what the version is. And to actually create or generate the package, you'd use the Guild package command. In this case, we provided an upload flag, which will tell Guild to upload the result to PyPy. Not everyone wants to do that. In fact, most cases you would not want to do that. But if you wanted to share this with the world at large, you certainly could. And we can see here that Guild is automatically figuring out that there's source code here, and it's including them automatically. But the package definition here that we saw earlier lets you fill in a whole lot of details, including dependencies and data files and everything that you would typically put in a setup.py, you can put in here. You can also use your own setup.py if you have a traditional Python package. That will work fine as well. This is just a sort of convenience to make creating packages much, much easier. Creating a setup.py is not always straightforward or simple or fun. But this is fun. Guild package upload, and then you're done. Okay, so that will package your project and upload, in this case, to PyPy, and that it will then be, somebody else can now search for it and install it and use it. So we're starting to see this vision of how layering or applying a packaged software model on top of, or sort of scheme on top of machine learning models can be quite powerful and very leveraged. Okay, so let me talked a little bit about this already, but let me talk a bit more about how to implement operations. Operations are implemented as a system call to project scripts. So again, we're not invoking an API here. We're calling your program at the operating system process level. So this allows you to implement it in any way you see fit. So there's no prescribed libraries or frameworks or languages. That is true of 0.6 on. The current released GA release is 0.5. That does require that you use Python, but that's going to change in 0.6. So we do support the Python-based frameworks, TensorFlow, Keras, PyTorch, MXNet, Scikit. Really anything that you want to use is fine. You satisfy the dependencies on your project, guess what? Using package dependencies. So if your project requires, or your model requires NumPy or scikit-learn or whatever, you just list that, and then when you install your packaged software, your packaged model, all that will come along with your package. So it just works. Okay, let me talk a little bit about workflow here. Guild does not formally define a workflow, but it supports workflow. We've already seen some simple workflows. So we've seen the train, the evaluate, and prepare data, and it looks like that. And usually your training operations will look like this. But we've also seen some fancier training alternatives. So fine-tune is, I have it listed differently from transfer-learn because it is. Fine-tuning generally means that you are taking a train model in one task and fine-tuning it in the same task. And you're adjusting things like learning rate or other hyperparameters to get a little bit more performance, but you're not doing fundamental learning. You're strictly fine-tuning it with some changes to your hyperparameters. Transfer-learn is very different. It is a form of fine-tune, but you're taking weights that were learned in one task and applying them to a totally different task. And how that is done is very different from a general fine-tune. And so in a lot of cases, you want to reflect this difference in your operations. So your model will have may have these three separate operations, or it may just have train, or it may just have transfer learn. Doesn't matter. Guild gives you the flexibility to define the models the operations that make sense for your particular models. You can also do things like crazy things like serve. And this is really not specifically related to training a model, but you're using it, and it's part of the model, and your deployment logic is tied to that model. So it's sort of an extension of that workflow. So you've got this great model that you've trained. Let's say it's an image classifier, and you want to go ahead and deploy it in an app. Maybe you want to serve it in a RESTful interface, or maybe you want to serve it in TensorFlow serving, or Deep Detect, or some other server. That would be an operation, and you could run that operation in the same exact way you'd run any other operation. You're just now extending your workflow into deployment from the training and evaluation. There's more, though. I mean, you can let your imagination go crazy. If you need to quantize your models, think of it as a form of compression, helping your models run in a more constrained environment. Your model might have a quantize operation. If you are deploying to TensorFlow Lite, you might have a TF Lite op that creates a TF Lite TOCO file, or TensorRT. The list goes on and on. Whatever your workflow needs will slot into Guild's operation scheme very naturally. You just add another operation. Okay, let me talk a little bit about runs here. Runs really are the main point. When you run an operation, you get this artifact, and again, it's a standard operating system process. It is associated with a unique file system directory. So every run gets its own run directory, always. You always get a unique run directory, so you're not, there are some exceptions. If you restart a run, it reuses the run directory. But new operations always get their unique run directory, and it contains the artifacts that are associated with that run. So any generated files, logs, including the TF event files. Your project source code is copied into a specific location, so that Guild can help you diff changes. So whatever the status of your project files were at the time of that operation, they'll be captured, so they're copied. So if there are any changes, maybe a progression or regression, and you're interested in what in the code has changed, Guild will let you very easily diff those things because it keeps track of the code. And any run metadata associated with the run. So your hyperparameters, configuration, that sort of thing. Okay, benefits of capturing runs. Well, there are a lot. It turns out it's a really useful thing to systematically capture your runs. Sort of the same way that you systematically keep track of revisions and source control. But I think runs are actually more important because let's say you took 3 weeks to train a model. Sure, you probably won't accidentally delete the checkpoint files, but having a systematic way to manage these things lets you not worry about those problems. Guild lets you delete runs, but it doesn't delete them. It actually moves them into sort of a trash area so that you can recover them. So little features like that to help you manage the artifacts of these important files, so checkpoints, frozen graphs, and data, they're all built into Guild. Many of its commands, if not most, are associated with discovering what's in the runs and managing the runs themselves. So delete and undelete. You can export and import. Lots of different features. I'll hit on this in the next slide, but by keeping track of your runs, Guild can sort of intelligently reuse runs. I'll give you some examples of that in the next slide. Of course, by keeping track of runs, you can compare run results. So we saw an example of that with TensorBoard, but Guild has a nice compare feature that will let you see differences in hyperparameters and metrics associated with the run. So for what what set of flags are associated with what losses or what accuracies, etc. doing comparisons across runs is very straightforward in Guild. So let's you do that. And then I mentioned code diffing and configuration changes. And of course, Guild does this, but I mean, conceptually, you can just do this as a best practice. I mean, what we're talking about here is keeping track of every run in its separate directory in a systematic, sort of consistent way, and then applying kind of common sense practices on top of that. Diffing, being able to generate a CSV file containing the your loss and accuracy and hyperparameters across your runs. People are doing this today. But you do have to be systematic about it. It has to be a best practice that's enforced. The nice thing about Guild is that it just does it for you. You don't have to think about it. Whenever you run an operation, you get a run, and then you get to do all the stuff with the runs. So again, in the context of packages, I'm installing this stuff. This is using the stuff. Not always obvious, but this is how, when I talk about using a model, I'm talking about all of this, the operations, and then taking advantage of the runs that the operations generate. Okay, real quick on dependencies here. I'm going to wrap up in a few minutes. So this is our very straightforward workflow that we've seen a few times now. And the dependencies, you can kind of imagine them, right? The prepared data generates some sort of artifact that train uses. So in the case of Keras, this actually comes from the fashion MNIST example. You would prepare the data by reading the images, applying some sort of normalization to the images in the tensors, the arrays, and then serializing those as NumPy arrays that can then be read by the training operation. So the prepared data is run as an operation, and it generates this stuff, a bunch of NPY files. And then when you run train, those NPY files are teed up. They're provided as inputs to the train operation. This is very common sense. This is not rocket science, but it's done automatically, so you don't have to think about it. Guild knows about dependencies across operation types. So train, in this case, depends on prepared data. So you can't run train unless you've run prepared data. And then when you run train, it automatically hooks up the files that train needs. So again, this would be something you would do manually. Guild just does that automatically. Okay, and then evaluate is the same idea. So train, in this case, we're talking Keras, and by convention, Keras likes to write things out to HDF5 files, and then evaluate is going to load the train weights from those files and then run inference on some test data and measure the accuracy. So that's sort of an example of dependencies in Guild. Okay, so some other benefits from these abstractions. We've talked about workflow. I hope you can see that there's a certain efficiency and flexibility by defining models and operations and not really going beyond that. Really, I think these they seem to me sufficient abstractions. If you have a dependency model, you can always figure out what operations you need to run as a part of a workflow. So you get a lot of flexibility out of a very simple abstraction. Guild supports convention of testing. We found in working with users that as you build packages, the packages can sort of become opaque, just like any black box pattern. And being able to run a regression test on the models in the package, very, very useful. So you can just say, run these checks, and in however much time it takes, you can see what works and what doesn't. And it's a very, very effective way of exercising a lot of code at a high level. And that, again, comes out of having models and operations. Guild supports location transparency. This really isn't strictly a benefit of models and operations. It happens to be a feature of Guild. Guild will let you run these operations locally, but you can run them remotely as well. So you can, by supporting packaging, you can package up your work, deploy it to a server, and run it remotely. And Guild just does that for you, so you don't have to think about it. And then backing up and restoring runs. So those are some additional benefits. Okay, so to wrap up here, what Guild is after is taking the benefits of the packaging software ecosystems. And these are old. There's nothing new here. These are well-established patterns. But basically saying, I'm going to take some software and I'm going to put it in a format that can be really easily used. And it can be installed, experimented with, and used effectively without really any thought at all. And the goal is to see that happen with machine learning models, because really a machine learning model is just software. It's very complex software, and it's very sort of peculiar software. But it is software. At the end of the day, you're running programs, and the programs are doing systems things. And these operations codify the interface that a user would be interested in working with. So that's what's going on here. Okay, and just really quickly on the name Guild. Guild comes from the spirit of this term, an association of people for mutual aid or the pursuit of a common goal. And hopefully it's clear that this sort of packaging motif scheme is really about collaboration. It's about accelerating the adoption and application of machine learning through both for researchers who are doing sort of the cutting edge work on model development and innovation, through to research engineers who are helping to facilitate the application, really down even to application developers who can now consume these models and use them without knowing anything about them, by just following some documentation and running some high-level commands. So that's the spirit of Guild. Okay, I'm going to open this. I think we have some time for questions, but this is sort of a call to action here. If you're interested, use Guild for your projects. Documentation, I think, is pretty good. We'll have links at the end here to the website. If you have any questions or issues, you can feel free to open an issue on the Guild GitHub issue tracker. We have a Slack channel that's open to all, and not super active on Twitter right now, but that'll change as things start to roll out. Guild is fairly early. The 0.5 was the first generally available announced release, and 0.6 is sort of the first kind of follow-up release. So there's it's still early days, but we're going to sort of shift toward trying to get the word out on this. So follow on Twitter, and at some point you'll start to get some things. Star on GitHub. I don't know why I have that there. It feels dirty to ask for stars, but somebody said I should ask people to star it. I might take that off. But anyway, it's on there, so run over and star it. Here are the links. So I'll leave that up, and with that, conclude. And I'm not sure how do we have time for questions, and how does it work?
Oh, yes, we have time for questions. Can you see there's like a Q&A box?
I'm sorry, say that again?
Can you see there's
yeah. Oh, I do.
and there's like questions in there.
Okay. So let's see here. All right. So I'm just gonna. Okay. So I'll read. Can everyone see that? I'll summarize the questions.
Maybe you don't have to read the question. I can post it in the chat window so everyone can see it. So it's just you can just answer the questions.
Okay. Courses. Okay, so this is the first question, sort of a general question for career advice. I think I'll move that to the end if we have time. So here are the thoughts on interactions between Gilt and PyTorch. I'm not that familiar with Gilt, so I don't have an opinion on that. Can the data be diffed between runs? Yes, Gilt has. So Dennis asked the question: can the data be diffed? Well, I guess it depends on the data and the format. Okay, so probably not. I think what you mean is there sort of a visualization tool that can intelligently diff data. Given that data can be in virtually any format, the answer would be no. If the data happens to be in a plain text format, then certainly that's the diffing support in Guild is at the file level, and it does a good job with text diffing. In fact, you can configure it to use any diffing tool that you want. So if there did happen to be a tool that diffed, let's say, the TF record format, that would be a very interesting tool. I don't think it exists. But you could integrate that into Guild so that when you said, diff these two things, that program would be activated, and then you could see the differences. So the answer to that is yes and no, and it depends. Thomas asks, can Guild separate the development on training and production, deployment on training and production? Yeah. So the answer to almost any can Guild do something when it comes to operations is yes, because Guild is actually not doing anything. Guild is just passing through commands to what you provide or what somebody else provides. Guild models can be assembled to wire in operations from different packages. An example of that is the tfserve package. There's a G package tfserve, which lets you very quickly wire in a serve operation with no code at all. It's just configuration. So if you have a production versus let's say a test environment and a production environment, you would define the operations like the deployment operations that suited your environment. It's going to be very specific to your environment, but you can wire that up with an operation, and the operations you can parameterize them with flags. So you might say deploy environment equals production, but your code would have to do that. Guild does not do that sort of thing out of the box unless there's a package that supports it out of the box. I'm not familiar with DVC. I'm going to have to go take a look at that. How is Guild AI different from DVC? I'll have to take a look. Curious now. Let's see. Can I go look? DVC, Disney Vacation Club. I'm sure you don't mean that. ML, machine learning version control. Oh, interesting. Yeah, it's probably quite different. Guild is sort of a Guild wants to wrap things and integrate things, and so this DVC might be something that is integrated into Guild as a diffing feature, or something that you could configure yourself to be integrated. What's the next big design change that would be good for Guild? Well, I can talk about 0.6. 0.6 is pretty exciting, I think. It's a move off of a TensorFlow only messaging, so PyTorch and MXNet and all, so the major usual suspects in Python world will be supported, but it will also support anything. It will sort of be open to Java or .NET or any other implementation. So that's kind of a big thing. And then the other thing that 0.6 will be hyperparameter tuning. There's a couple things. There will be formalized workflow, and then hyperparameter tuning. So if you think about what we're talking about here with running things and automated running, it kind of makes sense to be able to automate the hyperparameter optimization problem. I mean, this is easily the #1 requested feature. So if I can run train, why can't I run it? If I can run it manually, why can't I run it automatically and have Guild figure out what the optimal hyperparameters are for this particular operation, given loss or accuracy. And so that will land in 0.6. Beyond 0.6, I have not thinking too far beyond that. But if you've got any ideas or have features that you'd be interested in, please open a GitHub ticket, and would love to hear your thoughts.